Lecture number 3. What we're talking about today is the way in which water influences different climates around the world. The way in which water circulates across the planet in both, once again, the surface and the deeper, and how this creates short-term and long-term circulation. We'll also look at a couple of other factors of land formations that help to form our climates in different areas as well. Okay, so the first term is called gyres or gyres. I never can remember which one it is. But these are large-scale water circulation. Important. These two things are really important. It moves in a clockwise rotation in the northern hemisphere. So around to the left, just think about the hands of the clock as they move around. It moves in a counterclockwise in the southern hemisphere. Now, don't get confused about this whole thing about how water circulates in a bathtub. That's a myth. However, these large patterns of water actually do circulate in different directions. So the main thing that this does is that redistributes heat across the globe. And this keeps our climates moderated so we don't have wild swings. Water is extremely important to the earth for so many different reasons. And so what this does is it moves the cool air from the poles toward the middle section, right, toward the equator. But then it also moves the warmth from the tropics up as well. It also influences which side, it matters which side of the continents that you're on. So if you're on a west coast, it's going to cause those climates to be cooler than if you're on the east coast. As you looked at that video about weather patterns, this is a big deal. All right, big deal. All right, so these are our ocean currents. Now, what you're seeing here, and I should be able, let me see if I can shrink this down a little bit more. All right, so like I said, it moves, if you imagine that your equatorial line is running about right through here, right? So what you're gonna see is that in the northern Pacific, notice what's happening with these gyres. They are moving in a clockwise rotation this direction. All right, there's the Kuroshio is one of the currents, and then there's the California current that comes off here. In the south, you'll notice that the wind patterns are moving in this direction, or the water patterns are moving in this direction. All right, so they're counterclockwise. Now, what this does is it influences the way in which these different sides of the continent get their warmth. Now, I also want you to pay attention over here to the North Atlantic as well. So you'll notice that the northern wind patterns are moving in this clockwise rotation. There's a really important one that comes through that influences our weather greatly. And that is what happens as it moves along. It kind of comes up in here into the Gulf. Now, as it moves into the Gulf, it's going to kind of get trapped. And what that does is it creates extremely warm water, right? So that extremely warm water, if you've ever been down there, it's like a bathtub, right? It gets really, really warm in the Gulf. And that's because it sort of gets caught up in there. And then we have our warm air from the sun influencing that as well. So it's still in that tropical region and it's going to get really warm. Now, when it finally does move its way out, it comes up along the eastern seaboard in what's known as the Gulf Stream. And this creates a very warm eastern side of the United States. Whereas if you're over in California, if you've ever been over there, what you'll notice is that if you go into the Pacific Ocean, you're going to get cold. It's cold over there, right? I can't do it. But if you're over even on the same, if you were on the same latitude line across here, and you're in South Carolina, and you get in the water in the summer, it's warm, really, really warm. And the reason is because of the Gulf Stream. All right, so as it brings that warm air, And this influences the weather patterns and the climate that you're going to have on either side. So that cool air in California, that cool water, is actually going to serve to keep that climate not only more moderate, and it's being moderated by that large Pacific Ocean, it also is going to strip the moisture out of the air, which means California, for the most part, in Southern California, you're going to have a drier climate than you are in someplace like Southern California. Now, there's a couple other things that play into here as well. Now, what happens then, if you'll notice, is it comes along in the air along this Pacific, right? So as it moves along, it's actually heating up, right? Because it's staying with that more direct angle of insulation on that water, so the water's going to get warmer. But as it circulates up in this direction, so Japan is like our eastern seaboard. It's warmer than it really ought to be. If you looked at where it falls on latitude lines, it's warmer than it ought to be. But as it moves northward, it's going to cool off, right? So you're moving more toward the poles, the water is cooling, and so then as it falls down here along this direction, it's going to bring that cooler water down. In the Pacific, you have just the opposite kind of happening. You're coming from the south, where the water is down here along this Antarctic circumpolar current, and you're going to see a video that I've got for you on that. It's going to get super, super cold. All right, so it's going to move up along the coastline of Chile and Peru, and as it does, it's going to bring very cold water, just like the California coast. So along this western side, you're going to get a cooler side to it than you are over here on the South Atlantic. Okay, so on that end, it's coming from the warmer equatorial water and then bringing it down warmer on that eastern side. So this happens all across the globe in kind of the same fashion. Eastern sides of the continents are warmer, western sides of the continents are cooler because of the way the water circulates. Now, these circulation patterns are quick. All right, they're not long term. They're very, it's weather, it's moving around. The other thing is that, and I'm smiling, but I'm not. If you've ever heard of the Great Pacific Garbage Patch, it falls in line with these gyres, and every single one of these gyres, every single one of them has their own garbage patch. The Gulf actually has its own little garbage patch out here. Now, the Pacific one was the one that sort of got the big press, and it's very large, but what that means is that we are trading trash with Asia. They send their trash to us, we send their trash to them. So we're not in isolation out here. We are one global system, and we are tied together with our atmosphere, and we're tied together with our water. So when we look at this, not only with plastics, but chemical pollutants as well, and they will travel along these patterns that are outlaid in the gyres. Okay, hope that clears things up. Okay, another weather pattern is called El Nino. So what happens here, and this has to do with a lot with the wind patterns and also the gyres. Trade winds, remember they're traveling toward that westerly direction in that ITCZ, right? So they're in that midsection. They're traveling westerly, or easterly. Excuse me. They're going easterly, and so as they're moving eastward or from the east, what will happen with El Nino years is that those trade winds will kind of slow down, and many times they will actually reverse course. Now, I've got a video for you to watch. This is called ENSO or ENSO, but it's El Nino. So you've probably heard of El Nino before. And it happens usually in December, which is why it's called El Nino. It's called the baby child because it comes near Christmas time. La Nina is a kind of weaker version of El Nino. And so pay attention in the video. They don't really know why it occurs. Like it's not a real set pattern for why these weaken and go the other direction. But what we do know is that it suppresses upwelling. So if you'll remember when we talked a little bit about how nutrients move from the bottom of the ocean toward the surface, particularly along the coast of Peru is where this happens. So if you come back here and look, you'll notice how these are circulating like this. What will happen with El Nino is it'll essentially turn around and reverse its course and start going in this. These will slow down and then they'll start to kind of go the opposite direction. So think about for just a second, if you had a glass and you dumped a whole bunch of sugar into it and you start stirring it around, if you're only stirring at the surface of it and you don't do anything to get to the bottom, all of that sugar is going to sink to the bottom. What happens with upwelling is that basically reaches down, and this occurs along the coastline. So if you think about the continental shelf, so let's say we have Peru here, and then the water, so our water surface is over here, right? So that's water surface. And then you have your continental shelf that actually comes down like this, and then it drops off down into the ocean. So usually what happens is this happens along the coastlines because we have shallower. So those gyres can come along here and stir up this area right here, but it doesn't get to the deepest part of the ocean. Okay, so most of what we see happening is along the continental shelves of this with this upwelling. So upwelling is a way in which we start to circulate nutrients back into the system. But El Nino will actually stop that, and so they'll see a reduction in fishing industry. We'll see it, and it also changes weather patterns. So what we'll see is that we'll have these as it shows here, it gets wetter along the southeastern United States and drier along southern Africa and Asia. So they usually look to see if it's a good year for an El Nino and whether it's going to be strong enough. So El Nino, got a video for you on that one. Okay, upwelling. Once again, we have surface ocean currents diverging, and then they cause deep water to come up to the surface. And what this does is it circulates the nutrients, which then causes our producers to become very, very productive, right? So we're going to have a lot of basis to the food chain, which then immediately starts to build things up. So if that gets suppressed, then you're not going to have as much productivity, which is going to cause your food chain to decline, your food web. Okay, another big important factor that comes into play with weather has to do with land formations. So different land formations can cause different kinds of microclimates, essentially. So what you're looking at right here is Oregon, the state of Oregon. And you'll notice that the Cascade Mountains run right along here. Now, it's green on this side, and it is brown over on this side, right? Oregon and Washington have both the wettest climates in the U.S. and the driest climates in the U.S. And it has to do with these large mountain ranges. So what's going on? This is called rain shadow, by the way. So you have your Pacific Ocean out here, right? So it's blowing across, and when it does, it's blowing in moist, warm air. All right, so think about Seattle. It always stays temperate, and it's wet. It's a rainforest up there. But the Cascades, then, what they do is the air, as it goes up, remember this is a property of air, as it starts to rise, it cools down, right? So as it cools, the capacity to hold water vapor lowers. So the saturation point goes down, which means it starts to strip out the moisture. So all the moisture stays on this westerly side of the Cascades. So, and then as it moves across, those clouds don't move over. They just stay right there. And so then on the this is called the windward side. On the leeward side of those mountains, that air is going to come down dry, no moisture. And so as it does, all the evaporation starts to happen, and now you have a high desert. All right, so this is a rain shadow. It happens all across the western part of the United States because we have all of our large mountain ranges over there. The Sierra Nevadas are over there, the Rocky Mountains, the Cascades, the San Bernardinos. All of those are going to strip out that moisture. And so it's going to leave deserts on that southeastern or the southwestern part of the United States. And that's a rain shadow. This also happens in South America with the Atacama Desert, which is on the other side of the Andes. Really cool place, by the way. You cannot believe how tall those mountains are. We went to, I went a couple of years ago, and we went up into those Andes mountains. Oh my. I've been in the Rockies before. You ain't seen nothing till you've been in the Andes. And the way in which the weather patterns happen down there is quite astounding. All right, the last thing that we're going to talk about is called the thermohaline current. All right, so we talked about the gyres, the fact that those are our surface, short-term water circulation. There's also this thermohaline current, which is a low, it's down deep. We're talking about deep water, and it travels, and it takes hundreds of years for one circulation pattern to cross. Now, what this does is it ties in all of the ocean currents together. So this is our one collective pattern. Why is it called the thermohaline? Thermo, temperature. All right, so this has to do with changes in temperature, which also changes our density of the water and the way it rises and falls. So once again, we're tying back in some terminology. Haline. Haline, what does that mean? It means salt. So when you have haline, it's salt. So this has to do with density and temperature and what salt does to dense water as well. So it takes both of these to cause this circulation pattern to happen. All right, so let's come over and kind of break it down for what's going on. So as it moves off Antarctica, and they've stretched Antarctica out. So what you're having is when it's in Antarctica, that water gets really, really cold. And so as it freezes, it leaves the salt behind. So if you had salt water and you started to freeze it, the salt is not going to freeze. The salt is going to start to fall out of the water, and it's going to start to sink. All right, so now we have salty, dense water. Okay, so that's along Antarctica because it gets super, super cold down there. And this is where it starts. And then it's going to move along. Let's change my pen. So it's going to move along here, along Antarctica, and it's going to be very, very cold and very, very deep. Okay. Now, it's going to keep traveling along, and it's going to start to go up into the Pacific Ocean. And as it does, it's going to go up toward the equator, and it's going to start to warm up. Well, what happens when fluids warm up? They rise. So we're going to start to see this water, this deep current, begin to rise. Well, it's going to keep rising and rising, and then it's going to circle back around where it's going to warm up even still. And it's going to rise above itself. So it's like a conveyor belt that's down here, and then all of a sudden it's above, and then it circles back over on top of itself. So that's what's happening. And it's going to stay along this equatorial line in this region for quite a while. And it's going to go into the Indian Ocean. And remember, this is all still warm. And then it's going to flow around Cape Horn down here, and now we have a cross, right? So we have more dense below, and then we have warmer above. It's going to come in here to the Atlantic side, and as it does, it's going to go along. It's still warm, still warm, still warm, until it gets up here toward Greenland. At this point, it's going to get cold again, right? And so it's going to start to freeze. And as it freezes, the salt water is going to be left behind, and it's going to get dense, and it's going to start to sink again. So now we have, in the Atlantic, we have two conveyor belts, one on top of the other. And they're moving along, and this cold is going to go back down, and where it's going to start all over again. So it's one continuous loop joining all of the oceans together. Now, this is a big concern. It takes thousands or hundreds of years for this to go along, but humans are influencing this. And the big spot is right up here at Greenland. So Greenland, unfortunately, is going through a major change. Because of climate change, it is warming up and is melting. Now, this melting has two effects to it. One, you have a white surface, right? So that white surface has a high albedo. But when it melts, what happens is it starts to get dull. So if you've ever been around snow that has melted, you know that it starts to get icky brown, gray color. That changes the albedo. All right, so now it doesn't have as high of albedo anymore, which means it's going to absorb more infrared radiation, which means it's going to melt faster. So now we have a positive feedback loop, right? Our positive feedback loop is causing Greenland to be runaway melting. And this is a big concern where they predict that we're past the point of no return with Greenland melting. Past the point of no return. This is us. We did this. All right. Now, what's happening is that currently, as it's melting, remember, cold water sinks. So right now, it's getting colder in this area, all off the surface, the coast of Greenland, because the water is colder. Right? So it's still going to sink, but we've already noticed that there is a slowing of the thermohaline current that is occurring. Y'all, if this stops, if this conveyor belt were to stop, what you're going to see is this circulation pattern is going to stop as well. This mixing of the ocean water is very problematic, because what it means is that it's going to isolate us. Certain areas are going to get warmer and certain areas are going to get colder. So when we say climate change, we mean climate change, right? It's not everybody gets warm all at once. It means we change water patterns, we change temperature patterns, we change precipitation patterns, we change. Some places are going to get colder for a while before they start to heat up. Some places that were hot are going to get hotter even still. Some places that didn't have rain now have rain. Some places that were dry were expecting rain patterns no longer have those rain patterns that are predictable. So this is a huge, huge problem. Something a lot of people don't know about. So when we talk about climate change, y'all, I'm telling you right now, there are a lot of people out there that have no idea that this thermohaline current thing even exists. All right, so now you know. All right. Hey, that's it. Okay, so that's the last of my lectures. Thank you.